What if I told you the key to the next AI revolution wasn't in some high-tech computer lab, but buried in the writings of ancient philosophers? Well, we're about to explore how a really radical shift in thinking, seeing the world not as a collection of static things, but as a set of dynamic processes, is creating a new kind of AI, an AI that can solve mysteries that have left us totally stumped for years. Okay, I want you to picture this. A brand new billion-dollar naval vessel, an absolute marvel of engineering, suddenly suffers a critical failure. Experts swarm the thing, they run diagnostics on every single component, every wire, every circuit, and they find nothing. Not a single part is broken. The ship just failed. Now, this isn't some sci-fi scenario. This is the exact kind of complex, incredibly expensive mystery that modern industries face every single day.
You see, in a system as ridiculously complex as a modern ship, a failure, say a tiny crack in a weld, it's rarely a simple, isolated event. It's more like the final act in a long, invisible drama. It's the result of a perfect storm of tiny little deviations in materials and machinery and operations that have been unfolding for weeks, maybe even months.
So why can't our current methods figure this out? Well, traditional root cause analysis is kind of like trying to understand a movie by just looking at a few random photographs. It sees static snapshots of data. It relies on human experts who, let's be honest, can't possibly track millions of variables at once. And it uses these predefined checklists of known problems, which means it's totally blind to anything new. It's always fighting the last war, not the one that's happening right now.
This means the real culprit isn't a thing at all. It's a process, a very specific, invisible sequence of events that unfolds over time. It's what you might call a ghost in the machine. And the problem is, all our tools are designed to look for broken components, not for ghosts.
So to find this ghost, we can't just build a faster computer. No, we have to teach an AI a completely new way to see reality itself. And to do that, believe it or not, we have to go back to a philosophical debate that's literally thousands of years old.
For most of history, our thinking has been dominated by what philosophers call an ontology of being. This is just our normal, common-sense view. The world is made up of stable, separate things. Tables, chairs, engine parts. But there's this other view, an ontology of becoming, which argues that actually, the world isn't made of things at all. It says the most fundamental part of reality is process, flow, and constant change.
The ancient Greek philosopher Heraclitus nailed this idea perfectly. He said, "You could not step twice into the same river." Think about it. What makes a river a river? It's not the water, right? That's always changing. It's the continuous process of flowing. Its identity is the change itself. And to find that ghost in the shipyard, we need an AI that sees the world just like Heraclitus saw the river.
Okay, but that raises a huge question, doesn't it? If reality is just this constant, messy flow, how does any mind, or for our purposes, any AI, perceive anything stable at all? How do we find patterns in all that chaos? Well, for the answer, we're going to jump from ancient Greece to 18th century Germany and a philosopher named Immanuel Kant.
So Kant was wrestling with a question that today we call the symbol grounding problem. And this is a massive challenge for AI. An AI can have the word causality in its database, but how does it connect that abstract symbol to the raw, messy data streaming in from its sensors? How does it actually know what causality looks and feels like in the real world?
Kant's solution was absolutely brilliant, if a little obscure. He called it the transcendental schema. The best way to think of it is like a template, or maybe a stencil that our imagination uses. A schema isn't a picture of a thing, it's a rule for how to recognize a pattern as it unfolds over time. It's the thing that gives an abstract concept a recognizable shape in time.
Let's break that down real quick. So you've got this raw data flowing in, temperatures, vibrations, sounds, whatever. The schema for causality acts like a filter. It's constantly looking for a specific rule. Does event B consistently follow event A? And when that pattern gets a match, the schema transforms that raw data into a meaningful insight. It lets the AI go, aha, that's a causal link. It is the very mechanism that turns noise into actual knowledge.
So, how do we take this amazing philosophical idea from a guy who lived hundreds of years ago and actually build it into an AI? How do we teach a machine to learn these shapes of time all by itself?
This is where philosophy gets computational. There's a new AI architecture called the curve ontology, and it does exactly this. It's built from the ground up to translate Kant's abstract ideas about schemata into something a machine can actually use, dynamic mathematical curves that it discovers directly from the data.
Now, people have tried to build Kantian AI before, but here's the key difference you can see here. The older models, they had their concepts hard-coded by humans. The curve ontology is totally different. It discovers its own concepts from experience. It doesn't start with objects, it starts with processes. And this is the wild part. It means it could potentially discover entirely new, maybe even alien, non-human ways of understanding the world.
So at its core, this AI works on a few really cool principles. Instead of being programmed with rules, it learns the recurring shapes of processes, the curves, directly from time series data. It then builds a bridge from those raw number patterns to high-level symbolic ideas, basically solving that symbol grounding problem we talked about. Everything it knows is built from the ground up, based on the dynamic flow of information, not static facts. So what does one of these learned schemata actually look like? Well, it's just a curve. This S-curve right here, for example, is a classic pattern of growth. The AI doesn't need to be told what growth is. It can discover this fundamental shape in everything from stock market data to cell division and just recognize it as a meaningful pattern that happens over time.
Okay, so we've covered a lot of philosophy and AI theory. Let's bring this all back down to Earth, back to the shipyard, and see how this new AI actually catches our ghost.
So, how does it hunt the ghost? First, this AI deep research agent just drinks from the fire hose, ingesting massive streams of raw sensor data from the ship. Next, it independently sifts through all that noise to discover the fundamental curves, the unique temporal signatures of both healthy and unhealthy processes. Then, its symbolic layer starts connecting the dots, learning rules like, hey, when curve A shows up, curve B tends to follow. And finally, it pieces together the full story, identifying the exact temporal signature that leads to failure.
And there it is. The ghost is caught. The AI delivers its finding. The root cause isn't a broken part. It is a specific, dynamic process. A heat spike curve in the welding torch, followed by a vibration flutter curve in the metal, consistently, predictably creates a micro-fracture curve. A problem that was completely invisible to human analysis becomes crystal clear once you can finally see the shape of time.
This is about so much more than just building better ships. Adopting this process-first view of the world, this opens up a completely new paradigm for artificial intelligence. Just think about what this really means. An AI that can find novel temporal signatures could completely revolutionize science by spotting hidden patterns in climate data or medical signals. It could identify the signature of a market crash before it happens. This shifts us from just reacting to problems to actually predicting them. We could even build systems that understand the dynamic flow of human emotion by learning the curves of our own physiological responses. The possibilities are huge.
At the end of the day, what we're talking about is moving beyond an AI that just memorizes and spits back facts. This is an AI that actually learns to generalize the fundamental shapes of reality, the very patterns of how things happen.
And that brings us to a final, really fascinating thought. For centuries, our whole understanding of the world has been shaped by a philosophy of static things. So if we build an AI that sees the world as a dynamic flow, as a constant process of becoming, what new fundamental patterns will it discover? What new shapes of time, totally invisible to us right now, will it show us?